Hi, 7th graders. I'm back here for another lesson on electromagnetism this time. So I'm going to start off with just quickly pointing a couple things out. So last week we were talking about magnets. So we learned that there's a north and a south polarity. And around the magnet there's a magnetic field that forms. Opposites attract, so south and north attract. And same poles repel, so south-south or north-north will repel. So this is a magnetic field in a magnet. A battery also can create a magnetic field. So this is a D battery, and you'll see that on the battery there's a positive up here and then the negative end here. So when you're putting it in a battery pack or some sort of electronic device, your remote control or whatever you're using batteries for, the negative always hits the coil end. You put it into the battery pack here, which is what we would be using in school. You guys would be doing this yourselves, but since we're not, I'm just showing it. Then it's connected to these two positive negative wires, and on the end is what's called an alligator clip, because chomp, 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 looks like a little alligator. Okay, so we have a positive and negative side. So question number 1, we're going to determine which end of the nail is positive or negative based on which end it becomes attracted to. So as you guys learned last week, there are certain metals that are magnetic. Not all metals are magnetic. So this nail does have the wire around it, but it's not yet connected to the power source of the battery. So if I bring it over to the pile of paper clips, I hooked that one. It actually will not pick up the paper clips, okay? So this is a non-magnetic metal, okay? So now what I'm gonna do is I'm gonna hook it up to the battery, and we're gonna try to figure out which end of the nail is north-south based on whether it attracts or repels. So now that we have the battery pack set up, we have the nail, the copper wire, attached to the alligator clips, which is attached to the battery. Now one thing to note is this is a copper wire. Copper is a very good conductor of electricity, if you guys remember that. And it's covered with plastic because the copper will get very hot once this stays plugged in for a while, so this stops it from burning yourself. So now we're going to try to see which end. So I have it, so my hand is still right now. It's holding it above the camera. And as I move it closer, you'll see the nail kind of swinging back and forth. So it's trying to align itself with the nail. And based on the fact that, so see, this nail is a metal nail, but I didn't want to stick to the magnet. So see how it's kind of hovering and sort of shaking back and forth? That is telling us whether or not it's trying to align. Now you'll see that, again, my hand is still, the nail is moving on its own. So this is repelling right now, right? It's moving away from the magnet. So repelling. So when I flipped it over, it was really trying to align itself with the magnet. You can tell it's kind of straighter, whereas the other way it was pushing away. So this tells us that the red clip, which is attracted to the positive end, is the south side, and the negative, which is connected to the black wire, was the south end. So you're going to fill that in your answer sheet now. All right, number 2, what happens when I hold a nail or paper clip close to the coil? Okay, remember from before, when this was not connected to the battery, did not pick up any paper clips. It was not magnetic. Now that it's connected to the battery, there's an electric current flowing through the wire, and it actually causes that nail to become magnetic. Okay, so I was actually able to pick up quite a few of them. Okay, number 3. Can an electromagnet pick up paper clips when the current is disconnected? Okay, so now I'm going to unclip. Okay, I'm going to pick it, I disconnected it. Now I'm going to try to pick up that set of paper clips again, and you can answer the question there. What happened? Can an electromagnet pick up paper clips when the current is disconnected? Number 3. All right, number 4. I'm going to add a second battery pack. Okay, so now I have 2 battery packs. 1, 2. All right. How do you think this will change the electromagnet? So you pause the video and answer that now while I'm setting this up. So I am connecting the black end, 2 different battery clips on one side, and the red, or the positive, on the other side of the nail. And we're going to see what happens. So we have that same group of paper clips. Now we have a double battery pack set up. Same amount of coils, more battery. So what's going to happen now? Let's see. If we increase the battery power, does it also increase how many paper clips we can pick up? And I guess I didn't count them before, but you can probably go back, rewind it, and count them. Is it more or less than before? Okay, so how did it change the strength of the electromagnet? All right, number 5. I'm going to use different amounts of coil now. So we just did 2 battery packs. This was about 10 to 12 coils on this nail. And now I'm going to try different amounts of coils to see how that changes the strength of the electromagnet. So I'm going to go back to 1 battery, but increase the amount of coils. So this one has about double the amount. There's about 22 coils on this one. I already counted them. That's how I know. I'm not guessing. Okay. And I'm going to hook it up again to the nail. So this is about twice as many coils. Let's see what it does. I add a couple more paper clips. All right. So more coils. Is it increasing the strength of the electromagnet? It doesn't really seem like it picked up that many more than it did before. What do you think? Yeah, actually it did pretty good. It's pretty strong. Okay. So now, based on what you know, how can you increase the strength of an electromagnet? So you're going to answer that now. And then we're going to go down to the last question, number 7. And you guys are going to fill in the chart. Okay, so we're going to count them this time. All right, so I'm going to go back to my 10 to 12 coils. I'm going to plug it in. It's not the smoothest video. Okay, so we got 10 to 12 coils. So with 10 to 12 coils, how many paper clips can we pick up? Let's see. And this can vary depending on if your battery starts to run out of power. If we were in class, I would be recharging the batteries. All right, 10 to 12 coils. Let's see. It doesn't really want to pick up a lot of them. All right, let's see what we got here. I got 1, 2, 3, 4. So 10 to 12 coils, I was able to pick up I was able to pick up 4 paper clips. All right, so let's do fewer. So I'm going to actually uncoil this. 1, 2, 3. So 4. I now have 2, 4, 6 coils. Okay, so before it was about 12 coils, 11 or 12 coils. Now it's about 6. So it's about half of what it was before. Okay, let's see if we can pick any paper clips up. Okay, so it's looking like fewer is not enough power. Okay, so that would be 0. Now more. So I had already pre-wrapped a bunch of these. So now I got, this one has about 22, so it's about double the original amount. It has about 22 coils. So let's try that out. And see how many we can get. Okay, let's see. Now I got 1, 2, 3, 4, 5, 6. So a few more, not quite double, even though we doubled the amount of coils. All right. So the way I wrote the chart was with one coil, with one battery, with 2 batteries. So I'm going to actually keep the 24-ish coils. And I'm going to do a double battery on this one and see how it turns out. Okay. So, ooh, yeah, we got a lot more on this one. All right, so again, we have about 22 to 24 coils, 2 battery packs, and let's count them up. All right, I got 1, 2, 3, 4, 5, 6, 7, 8, 9. Oops, you guys couldn't see that. So I got about 9 paper clips with doubling up the battery pack with the same amount of coils. All right, so that's pretty much it for the demonstration. Now you guys are going to move on to question 8. You're going to write a short summary about how changing the number of coils and the number of batteries affects how many paper clips an electromagnet can pick up. So how do you think you could increase the strength of an electromagnet? And then you're going to do a quick research. You're just going to research 2 ways that engineers might be able to use electromagnets, and you're going to provide 2 examples for me with an explanation of how the electromagnet is used within that product or machine or motor that they are using and what they're using it for. So if you guys have any questions, email me, and I'll be available to help you. All right, hope all are doing well, and I'll see you later. Bye-bye.